Antarctica, with its ice cap covering 5 million square miles, is the world's greatest scientific laboratory. But it's not the kind of laboratory into which you can go with a white jacket and work with complete comfort. However, personal comfort is indispensable to the best kind of work. And so I should say that of all of the Antarctic equipment we take with us, clothing is perhaps the most important. You might be interested to see how we dress. This is a familiar garment to you. This is just an ordinary windproof parka, such as you would wear over your outer clothing if you were skiing in Wyoming or Minnesota or New England. This is the kind of clothing we wear in the Antarctic summer. During the wintertime, however, when the temperatures get down to 40, 50, 60, 70, 80, 90, 100 below zero, you need something beside light woolen clothing and a windproof parka. And of all of the outer clothing that anybody has designed, this, I think, is the best. This is a quilted parka. It is filled with eiderdown, which for its weight is the warmest material anyone has found. Another very important innovation has been made in footwear. If you can keep your hands and feet warm, then the rest of your body is not apt to suffer. This is a thermal boot, 2 layers with an airspace in between. You need wear only a light pair of socks, and you can keep warm with this boot down to temperatures of 50, 60, or 70 degrees below zero. You can't wear it at 80 or 90 below zero because the rubber would get brittle and it would break. These are only some of the things that are important as we get ready for an Antarctic expedition. Now I think it would interest you to go back and see how they did it, in the early days of American exploration, beginning with the first and second Byrd Antarctic expeditions in 1934. Because I think the contrast between the way things were done then on the second Byrd Antarctic expedition and the way they do them now will give you a better understanding of the problems that still confront us. This is the Bear of Oakland, which took the second Byrd Antarctic expedition down to the Bay of Whales. As we near the Bay of Whales and the Ross Shelf ice, we know that we are near the end of our journey, and you see the men getting the ship ready so that it can be brought alongside the shelf ice. We don't know whether it's safe to anchor the ship to this or not, and so it's necessary to do a bit of exploring. A number of men get in a small launch, and they sail over to the edge of the ice, take a look at it, and make sure that it will be a safe place to which the Bear of Oakland itself can be anchored. Everything is all right, and now you see us taking a line from the ship, tying it alongside, and now the difficult and hazardous task of unloading supplies will begin. Good many of the supplies can be unloaded directly by boom. Some will be carried across this ramp. This looks hazardous, and it is. We don't know whether the ice is going to hold or not. Actually, it did hold, and so no real accidents occurred. Here you see the boom from the ship unloading the oversnow vehicles, which we hope will help in transporting material from the ship into Little America number 2. Things were carefully packaged before we left the United States so that they can be handled as quickly as possible when we arrive. Here, by the way, you see 2 light planes being offloaded. Notice that they are equipped with skis. But here the dogs are the most important of all means of transportation still. Most of the heavy tonnage from the ship to Little America will be hauled in by the dogs, and it will be the dogs who will carry out most of the oversnow transportation for the geological and other work that the expedition will do. The terrain between the ship and Little America is unfortunately rough. It lies in the Bay of Whales, and pressure ridges have pushed the ice up into these spectacular patterns that you see here. However, these men know the route because a man on skis has prospected it and put up flags to guide them. Now, of course, the oversnow vehicles couldn't possibly operate in terrain like this. But where the snow and the ice happened to be relatively smooth, they also were able to help in the task of bringing the many tons of supplies from the ship into Little America. Naturally, new instruments, new inventions do change the methods of Antarctic exploration. And yet there are certain things which do not change. The oceans that surround the continent are still the windiest in all the world. The waves are the highest. Whether you are sailing south on the 60-year-old Bear of Oakland or aboard a modern ship as I did with Deep Freeze #1, the percentage of seasickness is still constant. This looks somewhat like the pictures you saw of the Bear of Oakland. The sea does not change. These ships are larger. One of these is the great icebreaker, the Glacier, which weighs 8,000 tons as compared with 700 for the Bear of Oakland. But all icebreakers have round bottom hulls so that they respond very easily to the waves of the sea. If you're not a good sailor, the voyage to Antarctica is apt to be a voyage by rail. But the ships are still the great workhorses and must transport most of the supplies from the United States to New Zealand, thence to Antarctica. It's much easier now, however, and we can handle much, much larger items of equipment. You notice these landing barges, which became very famous in World War II. They're very handy down here in Antarctica because they enable us to handle heavy items of equipment like trucks and sledges, putting them into the landing barges as you see us doing here, and then taking them over onto the bay ice or onto the rocks as the case may be. Actually, we are offloading material here for Hallett Base, which is the one jointly occupied by New Zealand and the United States. Hallett Base happens to be in the midst of one of the greatest Adelie penguin rookeries in the world. But how much this has simplified operations is indicated as you look at the way in which this landing barge is coming up onto the rocks and letting a tractor haul a sledge loaded with heavy equipment right off the landing barge itself. Here at Kynan Bay, it was possible for the big ship to tie up alongside the ice. This makes things a great deal easier. Now you see it's possible to take material directly from the ship that may weigh several tons, loaded directly onto the sledges, and then it's hauled away by the great caterpillars. I suppose no single technological change has more profoundly affected Antarctic exploration than what you are looking at now. I want you now to look at one of our sledge train operations. Out in front goes the Weasel to show the way. Each one of these great tractors at which you are looking now weighs 35 tons and hauls behind it two 10-ton sledges heavily loaded with supplies. This single tractor train operation is handling about 250 tons of equipment, food, and supplies. If we had to do this same thing with the dogs as we did 25 to 30 years ago, it would take 8,000 to 10,000 dogs. Here is the helicopter, which is the taxi of Antarctica and enables us always to keep in touch with what's going on. Getting to Antarctica with our great modern icebreakers and cargo ships is much easier, much less hazardous than it used to be in the earlier days, and yet the establishment of bases presents problems quite as difficult as man has faced at any time. I think you will be interested, therefore, to see the contrasts that have come about with the application of new techniques to this second stage in the occupation of Antarctica. This is Little America #2, built in 1934. When I say built, of course, a good deal of the building is done before you go down there. The houses are prefabricated, and we put them together as you see us doing here. Here is one nearly finished, soon to be covered with its flat roof. Here are the airplanes, very carefully staked out against the heavy winds. Here are the over-snow vehicles. Here is an interesting picture. It shows you the difficulty of maintaining mechanical equipment in Antarctica. It's important that we have communication throughout the winter night, and so all of the houses are connected by tunnels. The walls of the tunnels, as you see here, are largely made of boxes containing food, so that we can get the food whenever we need it without going out of doors. 25 to 30 years ago, the establishment of a base was largely a kind of do-it-yourself proposition. I mean by that everybody helped. The scientists, the mechanics, the cooks, All of us pitched in to make sure that the houses were completed as quickly as possible. Now, under IGY conditions, so to speak, this is done by professionals. The Seabees of the United States Navy built all of the bases for our scientists to use. Here is a wonderful example of cooperation in behalf of a great scientific program. The general pattern of construction of the base we are building now is not unlike that of 1934 in the second bird expedition, except that we can use a greater variety of materials, and of course we've learned a lot about the best kind of insulation. However, the buildings should be connected so that we can go from one to another no matter how bad the weather is. This is an over snow kind of tunnel. This will be covered with burlap from which the snow will drift and enable us to move from house to house. We've been able to carry much heavier equipment. We can put up much higher towers for our antennae, which means better communication. This is a Raywin dome. This makes it possible to follow the balloons, which will be launched by the meteorologists to a much greater height than had ever been done before. This is the quickest of all kinds of structures. This is a Janesway hut that'll be covered with insulated material and will be usable within a matter of an hour or two. Here is one of the bases as it looks when it is completed. Because of the fact that the Navy Seabees complete all of the construction for the scientists, the latter can devote themselves entirely to their observations, and the program begins at once with a great deal more efficiency than was possible in earlier days of exploration. One of the unique scientific activities in the polar regions is the study of the aurora. In order to have that done most effectively, we have built a tower on top of one of the houses, and you have seen the man climb the ladder. Now he will go up into the auroral dome itself. In the old days, we used to have to do all of this by hand, as it were, by which I mean people had to be looking all the time at the sky if we wanted to know what was going on. Thanks to the invention of a very ingenious device known as an all-sky camera, we can have a continuous photographic record which can then be carried back to the warmth and comfort of a laboratory for study. He will reload this much the same way you might load any other camera, and then place it back up in the dome for the continuation of its record. One of the most important of all of the aspects of our total program in Antarctica is the study of the weather. We can't do this without knowing what's going on high above us in the atmosphere, and we can only find out about that by sending up balloons, which these two meteorologists are about to do. But we've got to follow the balloon. That's why we have the radar domes, which you saw a few moments ago, and the radar inside follows the balloon without us having to stand out of doors in the cold. And the information is relayed to this man down inside the warm hut. He traces the location of the balloon as it rises to heights of 50, 60, 70, or even 90,000 feet. The natural phenomena which the scientist is studying in Antarctica remain constant, so to speak. This means that the disciplines being studied now were also studied 25, 30, 40 years ago. However, modern inventions and techniques have profoundly changed the way we do many of these things. This is Dr. Polder and the scientific staff of the second Bird Antarctic expedition in 1934. This is a common sight you would see on any good expedition anywhere. At frequent intervals, the staff comes together to talk about their mutual problems. Here we're on top of the snow, on top of the house indeed. And the little rectangular gadget you saw there is the old-time equivalent of an auroral dome. There were no all-sky cameras. The only way to study the aurora and the atmosphere and observe such things as meteorites was to do so by the use. To do that most effectively and to get a continuous record, Dr. Polder invented this device. You see, here are 4 chairs. They're attached to a rotating stand which enable the men to sit down and on each one look out of the glass-covered porthole. These positions aren't comfortable, and it's important to check each other's results. So they rotate every little while, and each one thereby gets another look at a different part of the sky than he has seen before. This is an assignment to which a man does not stay very long. Outside are the radio antennae, familiar things, of course, to all expeditions. I should guess from the way these men are wiggling their feet that the time of their assignment is about over and they'd like to come down. Here's a meteorologist not taking a nap, but getting ready to follow the course of one of the balloons. He can't do it very well from being inside the house. Actually, the balloon must be followed by a theodolite out of doors in a snow house, as you see here. Probably in few areas has technology so greatly increased the efficiency of scientific observation as in meteorology. The balloons are sent up, but the radar is not yet invented, and the only way they can be followed is with this theodolite. I don't remember what the temperature is here. It might be 20, 40, 50, or 60 below zero. And the man who watches the theodolite, traces the balloon, telephones the information inside to the meteorologist, who records it very much as we are doing it now. The difference is in technique, not in the end result. Modern techniques enable us to follow the balloons much higher than was true before. This is the Oceanographical Laboratory, and these men are testing the salinity of water which has just been taken from the Ross Sea. As I've said, some things remain constant, and amongst these are the appetites of men. All men want to eat. All men like to eat. Take a look, if you will, at this menu for June 22nd, 1934. I think you will agree with me that this might be good food anywhere in the world. It's not easy to overemphasize the importance of good food. It is the first necessity of keeping morale high. And we've always had good food, but we can have much better food now. And look at the steaks this man is taking out of the storage container. This was done just a little while ago at McMurdo Sound. This is the way they live now. Because of modern techniques, we can have a great many more kinds of food than was possible with the earlier expeditions. Frozen vegetables and things of that sort have been a godsend to comfort of Antarctic living during the winter night. One of the very most important developments in broadening the scope of Antarctic exploration has surely been the airplane. Planes were used in Antarctica by Sir Hubert Wilson and Admiral Byrd, then Commander Byrd, in 1928. Even so, at that time, dogs were more important for over-snow transportation. Think how different it is today. That's the tail end of the tri-motored Ford, which was left in Antarctica at the end of the first Byrd expedition in 1930. It's being dug out by the second expedition in 1934 to see if it is still usable. This is a magnificent old plane. It looks as though it were easy to start. Actually, they have been warming up the motor for a long time, and the oil has been heated inside on the kitchen stove, poured into the motor, and then the propellers start. However, it's going to take a little while to start the other 2 propellers. It's necessary to haul it out of its hibernation by the use of dog teams. When I went to Antarctica first in 1928 as a member of the first Byrd Antarctic expedition, we had to take all of the planes with us aboard ship in crates. Then they were unpacked and put together and flew. Now the planes of any size are able to fly all the way. That's why it is necessary to spend so much time developing an adequate runway near our main logistic base at McMurdo Sound. These great rollers are kept in continuous operation, hauled back and forth by the tractors to level out and keep hard the airstrip at McMurdo Sound. This is known as Williams Air Facility. More than 100 planes have been based here during the International Geophysical Year operations. Planes of all sizes, from little ones that can land on skis to the gigantic Globemaster, which you see coming in now from New Zealand after a flight of some 2,300 miles. The sea ice is about 12 feet thick. This is the only kind of landing that anyone has ever been able to find in Antarctica for wheeled vehicles. In this continent, completely covered with ice, no one has yet found a flat place on the land where an airstrip could be built. This is a hazardous activity, and I think it's a great compliment to the Air Force and its personnel that they were able to carry out so many flights and carry them out safely without any very serious loss. I think you'll be interested to see how one of these great Globemasters operates. Notice the tractors hauling material in beneath the tail of the plane. There is a great opening on the belly of the plane. Material is put onto an elevator. It's hauled up into the belly of the plane and then pushed along on a track to the front or to the rear, as the case may be. And then when the plane has flown over its objective, this door opens on the bottom and all of this material will be airdropped. All of the equipment, all of the material used at the South Pole, except the personnel themselves, were delivered there by airdrop by these great Globemasters. Likewise, Byrd Station could not have been supplied and operated without the cooperation of the Air Force and the supply made possible by the activity that you see now. Most of the material is dropped by parachute, especially if it happens to be delicate instruments or anything of that sort. Parachutes are expensive, however, and so sometimes the material is free dropped. Here's a smaller plane. Notice the flames. That plane has taken off with JADO assists or jet assists. It can take off with a heavier load than would otherwise be the case. Here's one of the Globemasters parachuting material down over the South Pole. Notice how gently it goes down. On the other hand, if it's lumber or a gasoline drum that will not be hurt by the fall, it may be dropped and land free, as you see here. But it's always safer to have 1, 2, 3, sometimes as many as 5 parachutes to let something like this down. Changing techniques in polar exploration have not changed Antarctic seasons. The summer draws to an end, and everyone knows that he will be isolated until the sun returns. If you're at the pole, 6 months without the sun. Along the coastal regions, like our main logistic base at McMurdo, the sun will return after about 4 or 5 months. The Antarctic summer comes to an end in March, and all of the personnel who are not going to winter over have got to depart. The departure itself is a kind of solemn occasion, because the people left behind know that no one can come back for 6 months at least. Here they all turn out to watch the plane disappear in the sky, leaving its beautiful vapor trail behind it. 25 years ago, the second Byrd Antarctic expedition did not watch planes depart. They watched the Bear of Oakland depart into the fog. But the sense of isolation was the same. In this program, we have tried to provide a kind of stage setting for the total IGY scientific activities in Antarctica. When I say stage setting, however, the word needs a little bit of amplification. It isn't easy to bring a continent as large as the United States and Europe combined into a stage, or should I say onto a stage. It still is the world's biggest geophysical laboratory. it is the most difficult of all areas of the world to study and to explore. However, thanks to the tools that have been developed by the physicist and by the engineer, observations can be made more easily, more accurately, and much more widely than has ever been true before. And so we are today writing in Antarctica another record of man's conquest over his physical environment. You will hear these words from time to time, and you should hear them because they are the essence of the whole International Geophysical Year program all over the world, not just in Antarctica. This is National Educational Television.